Hey guys, my name is Tom. In this video I am going to show you the solution to a common type of exercise in introductory probability. So what we have is this. You are given the distribution function, the cumulative distribution function. And it has the following form. It's big F of x equals big curly brace 1 minus e to the negative 2x, and then this holds for x being greater than or equal to 0, and then this function is 0 for x less than 0. So this is the cumulative distribution function, has this appearance. The question is, find the density function, find the probability density function. So how do you do it? And the key step here is to observe the following, that little f is the derivative of big F, like this. So in our case, what we have is the derivative of 1 minus e to the negative 2x is the following. I'm going to do that on the side. 1 minus e to the negative 2x. Well, the derivative of 1 is 0. That's constant, so it goes away. And then the derivative of negative e to the negative 2x is by the chain rule. Negative e to the negative 2x times the derivative of this term in the exponent. So that's just negative 2. So what we have now is 2e to the negative 2x. So this becomes 2e to the negative 2x, and this holds for x greater than 0. And of course the derivative of 0 is still 0, so that goes over here for x less than 0, okay? Like this. So this little f is what we call the PDF, the probability density function. Big F is the cumulative distribution function, okay? And to obtain little f from big F, you use the process of differentiation as I've shown you here. Let's separate this with a line. I'll use a different color so it's easier to see. Okay, that these are related but not the same. So this is the CDF, and by the process of differentiation from the CDF we obtain the PDF. Okay? And this is the process of differentiation in this box. There you go. And now another common kind of question, of course, in this context is find the probability that x is greater than 2. Okay? So you have a couple of choices. You can use the PDF and you can integrate, or you can use the big F and handle it that way. To review integration, let's take a look. So the probability that x is greater than 2, okay, so it's the value of the random variable is to the right of 2, is the integral from 2 up through positive infinity of little f. Okay? So that's 2e to the negative 2x dx, like this. Okay? So let's integrate this. So remember, this means the probability that x is greater than 2 is given by the value of this integral. Let's integrate this. Now, how do we handle this kind of integral? So you can use U-Substitution, or you can make the following observation. That the 2 is constant first off, so you can pull it outside the integral. So you have 2 2 to positive infinity of e to the negative 2x dx. Now the next step, what we have now is to handle integrating this portion right here. So just to review, let's introduce U-substitution. So how do we use this technique? Well, notice that I can let u be negative 2x. Okay, so let's write that on the side. U equals negative 2x. Then du equals negative 2 dx, which means dx can be solved for as negative du over 2, right? I divided both sides by negative 2. So dx equals negative du over 2. Now we can return to the integral and make the replacements. So the original 2 from here is still kept, but then we have a new integral that looks like this. And I'm going to separate it with a different color. Integral of e to the u du divided by or multiplied by negative 1 over 2. Okay. So let's work on this now. Notice that this blue 2 and that 2 little one here in the bottom cancel. So all that remains is the integral of e to the u. This is negative. That negative does not cancel. Du. So now what is the function whose derivative is e to the u? That is itself. That's the same function, e to the u. So at this step we end up with negative e to the u as the antiderivative. Let's return to the original variable x. So u equals negative 2x. So let's rewrite this now as negative e to the negative 2x. Let's plug in the limits of integration. So one of them is positive infinity, the other one is 2. So now let's evaluate this expression between these limits. So here to handle this one, first of all, that negative, factor that out. Negative 1 goes out, and all that remains is the following. The limit as b goes to positive infinity of e negative 2b minus e to the negative 4. This limit of e to the negative 2b as b goes to positive infinity, that's 0. That just completely disappears. So all that remains is negative 1 times negative e to the negative 4. This negative times that negative is positive, and all that remains is e to the negative 4. Okay. So just so we don't forget, this e to the negative 4 represents the probability that the random variable x is greater than 2, meaning it's it's between 2 and positive infinity. That is e to the negative 4th. Okay, that is that probability. So to review, the key concepts are these. This is the CDF, big F. To find the little f, or the PDF, you differentiate as I've done here. And here we differentiate it using the chain rule. To find the probability that x is greater than some value, such as this one. This is the exponential distribution here, so you write this integral. The 2 is constant, factor it. We have reviewed here the process of U-substitution to ease the differentiation integration process rather. Cancel this 2 and that 2. And to differentiate, replace u with negative 2x because that's how we defined it here. Stick in the upper and lower limits of integration. Evaluate this quantity. and obtain your final answer of e to the negative 4 as the probability that x is 2 or more. 2, from 2 to positive infinity. There you go. Thank you for watching.